Next up, we're going to take a look at angles of depression and of elevation. Now, let's say that two friends have decided to go to a football game, but they weren't able to get tickets together. So one friend sat in the club seats while the other friend sat up in the nosebleeds. Their perspective on the game is they're both going to be elevated above the playing field. But let's look at how different perspectives change whether we have an angle of depression or whether we have an angle of elevation. So the first thing that you would want to do is draw in eye level. And you can see that eye level is going to be parallel lines for all three of these people. So the two friends sitting in the stands and then the quarterback on the field. So from the quarterback's perspective, what we would do to determine if we have elevation or depression is when we look, we're going to use that horizontal line for his line of sight. Then if we're looking at the friend that's in the club suites, we're going to use his line of sight, his horizontal line of sight as well. So if the quarterback happens to look up into the stands and sees this one friend, he's going to be looking like this. So from his angle, his horizontal line of sight to the line of sight to this person in the stands, that is going to be an angle of elevation. But if we change the perspective and we say instead of the quarterback looking up into the stands, the person is looking down onto the field. Well, what that means is we're going to use this horizontal line of sight now, and then looking downwards, and you can see that from there to there, that's an angle of depression. So if you're looking up, it's going to be an angle of elevation. Looking down, it's going to be an angle of depression. Again, whether we have depression or elevation depends on which person is the perspective coming from. So if at some point during the game, they get a hold of each other and they say, hey, I'm in this section, I'm in this section, and the friends look up and they turn and they wave to each other, then the horizontal line of sight here is going to be looking up to see this friend. But from this friend to this friend, it's going to be looking down. So you're going to have a line, or you're going to have an angle of depression instead of elevation. Now what's interesting is that it honestly doesn't really matter whether you're talking about elevation or depression, because we know that this line here is parallel to that line, is parallel to that line. So these lines really, what they represent is transversals. So these are alternate interior angles here, which means that these two angles, whether we're talking about elevation or depression, are going to be the same angle. From here to here, again, they're going to be the same angle because we're talking about alternate interior angles with parallel lines. And so that's how we're going to look at angles of depression and elevation. Remember, it's always from the perspective of the person or the thing that is looking down or looking up towards something else. If it's looking up, then it's an angle of elevation. If it's looking down, then it's going to be an angle of depression. For problem number 1, we want to identify do we have angles of depression or angles of elevation for angles 1 and 4. 2 and 3, you're going to do it in the guide on your own. So if we look at angle number 1, angle number 1 is the view that the bird has looking towards the person in the hot air balloon. And we can see that the horizontal line of view goes down in order to be able to see the person in the hot air balloon. So that means that this is going to be an angle of depression. Now for angle number 4, you have, let's say it's somebody is at the base of this mountain and is looking towards the person in the hot air balloon. So their horizontal line of sight, if they were just looking straight out, is going to be here, and they have to look up to see the person in the hot air balloon. Since they have to look up to see the person in the hot air balloon, then they are looking at an angle of elevation. So for problem number 2, the book wants you to imagine that you're standing in a field and 53 feet away from you is a wind turbine. What they want you to do is to calculate how far above the surface of the ground is the hub of that wind turbine. So you're given a little bit of information. First off, you're told that your eyes are 5.5 feet above ground level. That is not extraneous information. You are going to need to use that information. the angle of elevation, because we're going from the horizontal line of sight here up to see the hub, is 56.5 degrees. The distance, again, to the turbine is 53 feet, and we want to find out how tall is that. But we also need to add 5.5 feet here to account for the fact that your eyes are 5.5 feet above the surface of the ground. So let's look at the information that we've got and what we can do with it. We've got this angle here. We're looking for the opposite side of this right triangle, and we're given the adjacent side. So opposite and adjacent tells us to use tangent. So we're going to go tangent of 56.5 equals the opposite x over the adjacent 53. So again, we need to isolate this x, and to do that, we're going to multiply both sides by 53. So that's going to give us 53 tangent of 56.5, and then at this point, don't forget about your 5.5. So add 5.5 over here. Now, important to know, this 5.5 is not being added to this 56.5. This right here is something that needs to be worked out and then multiplied against the 53 before this 5.5 is even added. Now, if you've got a graphing calculator, this should do it for you. It knows how to do order of operations. So if you plug in 53 and then tangent of 56.5, close out your parentheses, that's why the parentheses is important, plus 5.5, it's going to give you a solution of 85.57. So x, or x plus 5.5, the distance or the height, I'm going to change this from x to the height. The height is going to be 85.57 feet tall, or approximately 85.57 feet tall. So again, whenever you're doing this, you need to make sure that you take into account your trig function, but you've also got to take into account, do you have any extra information that actually does need to be used in order to come to the correct solution? In problem number 3, we're told that if you are riding on an airplane that is making its approach to the Oklahoma City airport, it needs to begin making a descent at 3 degrees from a height of 2,714 feet above sea level. The airport itself sits at 1,007 feet. So what we want to find out is how long is this glide path going to be to the nearest tenth of a mile. So what we've got is 3 degrees here, and we can also say by alternate interior angles that we've got 3 degrees right here. Because, and the reason why I'm doing that is because over here, I've got to figure out not how high in the air it is above sea level, but how far is it above the surface of the ground where it's going to make touchdown at. So we've got 2,714 minus 1,007, which is going to give us 1,707 feet. So now we've got enough information here to begin figuring out what is this length, because that right there is going to be a right angle. So we've got this angle here at 3 degrees, and we have the opposite piece of information, and we need the hypotenuse. So we're going to go the sine of 3 is equal to the opposite 1707 over the hypotenuse, which is x. So now we've got a situation that we haven't encountered before, where we've got the variable in the denominator as opposed to being in the numerator. Don't worry, it's pretty simple to get to the solution. We know that whenever we've got something that we want to remove from the denominator, we just multiply everything by that denominator. So we multiply both sides by x. That's going to give us x sine of 3 equals 1707, because this x and this x cancel out. So now x is being multiplied against sine of 3. So how do we get rid of multiplication? We go division. So we divide out sine of 3, and you get x equals 1707 over the sine of 3. One thing that you may want to remember in order to give yourself a little bit less work to do is that anytime that you have this set up here where the variable is in the denominator, this and this are just going to switch places. So you can see that sine of 3 went into the denominator, and x took the place of sine of 3. So now to figure out what x is, all we're going to do is do 1707 divided by sine of 3. So go into your calculator, type in 1707, divided by, and then sine of 3, and then close off your parenthesis, and you get 32,616. Now, 32,616 is the number of feet that that the glide path is. So 32,616.19, and then it goes on and on and on. What the book is asking for, though, is how many miles to the closest tenth of a mile. So leave your answer as is. Leave it with all of the decimals there. And you know that there are 5,280 feet in a mile, so we're going to divide that by 5,280. So divide your answer by 5,280, and that's going to give you 6.17. So since this wants it in miles to the nearest tenth, that's going to give us approximately 6.2 miles that the airplane is going to glide down to the runway.